हेलो दोस्तों, बिगनर्स पॉइंट में आपका स्वागत है। और अभी हम कर रहे हैं इकोनॉमिक्स। ठीक है। इससे पहले के चैप्टर नहीं करे हैं तो प्लेलिस्ट बना रखी है, उसमें जाकर देख सकते हैं। थर्ड चैप्टर है ऑर्गेनाइजेशन ऑफ डाटा। इंट्रोडक्शन। इन द प्रीवियस चैप्टर you have learned about how data is collected. You also came to know the difference between census and sampling. In this chapter, you will know how the data that you collected are to be classified. The purpose of classifying raw data is to bring order in them so that they can be subjected to further statistical analysis easily. Have you ever observed your local junk dealer or kabadiwala to whom you sell old newspapers, broken household items, empty glass bottles, plastics, etc.? He purchases these things from you and sells them to those who recycle them. But with so much junk in his shop, it would be very difficult for him to manage his trade. If he had not organized them properly to ease his situation, he suitably groups or classifies various junk. He puts old newspapers together and ties them with a rope, then collects all empty glasses bottles in a sack. He heaps the articles of metals in one corner of his shop and sorts them into groups like iron, copper, aluminium, brass, etc., and so on. In this way, he groups his junk into different classes: newspapers, plastics, glass, metals, etc., and brings order in them. Once his junk is arranged and classified, it becomes easier for him to find a particular item that a buyer may demand. Likewise, when you arrange your school books in a certain order, it becomes easier for you to handle them. You may classify them according to subjects, where each subject becomes a group or a class. So, when you need a particular book on history, for instance, all all you need to do is to search that book in the group history. Otherwise, you would have to search through your entire of collection to find the particular book you have looking for. While classification of objects or things saves our valuable time and efforts, it is not done in an art arbitrary manner. The Kabadiwala groups has his junk according to the markets for reused goods. For example, under the group class, he would put empty bottles, broken mirrors, and window panes, etc. Similarly, when you classify your history books under the group history, you would not put a book of a different subject in that group. Otherwise, the entire purpose of grouping would be lost. Classification, therefore, is arranging or organizing things into groups or classes based on some criteria. Raw data, like the Kabadiwala's junk, the unclassified data or raw data are highly disorganized. They are often very large and cumbersome to handle. To draw meaningful conclusions from them is a tedious task because they do not yield to statistical methods easily. Therefore, proper organization and presentation of such data is needed before any systematic statistical analysis is undertaken. Hence, after collecting data, the next step is to organize and present them in classified form. Suppose you want to know the performance of students in mathematics and you have collected data on marks in mathematics of 100 students of your school. If you present them as a table, they may appear something like table 3.1, marks in mathematics obtained by 100 students in an examination. ये सब है मार्क्स ऑप्टेन करें. और you could have collect data on the monthly expenditure on food of 50 households in your neighborhood to know their average expenditure on food. The data collected in that case, had you presented as a table, would have resembled table 3.2. Both tables 3.1, 3.2 are raw or unclassified data. In both tables, you find that numbers are not arranged in any order. Now, if you are asked for the highest marks in mathematics from table 3.1, then you have to first arrange the marks of 100 students either in ascending or in descending order. That is a tedious, मतलब कि थकाऊ टास्क है, थका देने वाली चीज़ है ये. It becomes more tedious if instead of 100 you have the marks of 1000 students to handle. Similarly, in table 3.2, like this, you would note that it is difficult for you to ascertain the average monthly expenditure of 50 households, and this difficulty will go up manifold if the number was larger, say 5000 households like our Kabadiwala, who would be de- distressed to find a particular item when his junk becomes large and disarranged. You would face a similar situation when you try to get any information from raw data that are large. In one word, therefore, it is a tedious task to pull information from large unclassified data. The raw data are summarized and made comprehensible by classification. When facts of similar characteristics are placed in the same class, it enables one to locate them easily, make comparison, and draw inference without any difficulty. You have studied in the chapter 2 that the government of India conducts census of a population every 10 years. About 20 crore persons were contacted in census 2001. The raw data of census are so large and fragmented that it appears an almost impossible task to draw any meaningful conclusion from them. But when the same data is classified according to gender, education, marital status, occupation, etc., the structure and nature of population of India is then easily understood. The raw data consists of observations on variables. The raw data has given in table 3.1, 3.2 consists of observations on a specific or group of variables. Look at 3.1 for instance, which contains marks in mathematics scored by 100 students. How can we make sense of these marks? The mathematics teacher looking at these marks would be thinking, how have many students done? How many have not passed? How we classify the data depends upon the purpose we have in mind. In this case, the teacher wishes to understand in some depth how these students have done. She would probably choose to construct the frequency distribution. This is discussed in the next section. Classification of data. The groups of classes of classification is done in various ways. Instead of classifying your books according to subjects, history, geography, mathematics, science, etc., you could have classified them author-wise in an alphabetical order, or you could have also classified them according to the year of publication. The way you want to classify them would depend your requirement. Likewise, the raw data is classified in various ways depending on the purpose. They can be grouped according to time. Such a classification is known as chronological classification. In such a classification, data are classified either in ascending or in descending order with reference to time such as years, quarters, months, weeks, etc. The following example shows the population of India classified in terms of years. The variable population is a time series has it deficit depicts a series of values for different years. Population of India in crores 1951 में 35 करोड़ 61 43 71 54 81 68 91 81 2001 100 करोड़ 2011 121. In spatial classification, the data are classified with reference to geographical locations such as countries, states, cities, districts, etc. Example 2. Yield of wheat for different countries. 2013 country yield of wheat kg per hectare. Canada 3,594, China 5,000, France 7,000, Germany 7,000, India 3,000, Pakistan 2,000. Sometimes you come across characteristics that cannot be expressed quantitatively. Such characteristics are qualities or attributes. For example, nationality, literacy, religion, gender, marital status, etc. They cannot be measured, yet these attributes can be classified on the basis of either the presence or the absence of a qualitative characteristics. Such a classification of data on attributes is called qualitative classification. In the following example, we find population of a country is grouped on the basis of the qualitative variable gender. An observation could either be a male or a female. These two characteristics could be further classified on the basis of marital status as given below. Population male, female, married, unmarried, married, unmarried. The classification at the first stage is based on the presence and absence of an attribute, that is male or not male means female. At the second stage, each class is male and female is further subdivided on the basis of the presence or absence of another attribute, that is whether married or unmarried. Characteristics like height, weight, age, income, marks of students, etc. are quantitative in nature. When the collected data of such characteristics are grouped into classes, it becomes a quantitative classification. Example number 4, frequency distribution of marks in mathematics of 100 students. 0 to 1 frequency 1, 10 to 8 8, 20 to 36, ऐसे करके 100 तक 4 frequency हो जाएगी. Example 4 shows the quantitative classification of marks in mathematics of 100 students given in table 3.1 में हमने देख चुका है. Variable, continuous and discrete. A simple definition of variable which you have read it in the last chapter does not tell you how it varies. Variable differ on the basis of specific criterion category कसौटी. They are broadly classified into two types, continuous or discrete. A continuous variable can take any numerical value. It may take integral value 1, 2, 3, 4, fractional values 1 upon 2, 2 upon 3, 3 upon 4, and values that are not exact fractions under root 2, 1.414, under root 3, 1.732, under root 7, 2.664. For example, the height of a student as he or she grows, say from 90 centimeter to 150 centimeter, would take all the values in the between them. It can take values that are whole numbers like 90 centimeter, 100 centimeter, 108 centimeter, 150 centimeter. It can also take fractional values like 90.85 centimeter, 102.34 centimeter, 149.99 centimeter, etc. that are not whole numbers. Thus, the variable height is capable of manifesting in every conceivable value, and its values can also be broken down into infinite gradations, infinite gradations. Other examples of continuous variable are weight, time, distance, etc. Unlike a continuous variable, a discrete variable can take only certain values. Its value changes only by finite jumps. It jumps from one value to another but does not take any intermediate value between them. For example, a variable like the number of students in a class for different classes would assume values that are only whole numbers. It cannot take any fractional value like zero point 0.5 because half of a student is absurd. Therefore, it cannot take a value like 25.5 between 25 and 26. Instead, its value could have been either 25 or 26. What we observe is that has its value change from 25 to 26, the values in between them, the fractions are not taken by it. But we should not have the impression that a discrete variable cannot take any fractional value. Suppose x is a variable that takes values like 1 upon 8, 1 upon 16, 1 upon 32, 1 upon 64. Is it a discrete variable? Yes, because though x takes fractional values, it cannot take any value between two adjacent fractional values. It changes or jumps from 1 upon 8 to 1 upon 16 and from 1 upon 16 to 1 upon 32, but it cannot take a value in between 1 upon 8 and 1 upon 16 or between 1 upon 16 and 1 upon 32. Example 4 shows how the marks of 100 students are grouped into classes. You will wondering as to how we got it from the raw data of table 3.1. But before we address this question, you must know what frequency distribution is. What is frequency distribution? Frequency distribution क्या होता है? A frequency distribution is a comprehensive way to classify raw data of a quantitative variable. It shows how different values of a variable, here the marks in mathematics scored by a student, are distributed in different classes along with their corresponding classes frequencies. In this case, we have 10 classes of marks, 0 to 10, 10 to 20, say 90 to 100. The term class frequency means the number of values in a particular class. For example, in the class 30 to 40, we find 7 values of marks from raw data in table 3.1. They are 30, 37, 34, 30, 35, 39, 32. The frequency of the class 30 to 40 is the 7, but you might be wondering why 40, which is occurring twice in the raw data, is not included in the class 30 to 40. Had it been included, the class frequency of 30 to 40 would have been 9 instead of 7. The puzzle would be clear to you if you are patient enough to read this chapter carefully. So carry on. You will find the answer yourself. Each class in a frequency distribution table is bounded by class limits. Class limits are two ends of a class. The lowest value is called the lower class limit and the highest value the upper class limit. For example, the class limits for the class 60 to 70 are 60 and 70. Its lower class limit is 60 and its upper class limit is 70. Class interval or class width is the difference between the upper class limit and the lower class limit. For the class 60 to 70, the class interval is 10, upper class limit minus lower class limit. The class midpoint or class mark is the middle value of a class. It lies halfway between the lower class limit and the upper class limit of a class and can be ascertained ascertained in following manner. Class midpoint or class mark: upper class limit plus lower class limit divided by 2. The class mark or mid value of each class is used to represent the class. Once raw data are grouped into classes, individual observations are not used in further calculations. Instead, the class mark is used. Frequency curve is a graphic representation of a frequency distribution. Figure 3.1 shows the diagrammatic presentation of the frequency distribution of the data in our example above. To obtain the frequency curve, we plot the class marks on the x-axis and frequency on the y-axis. ऐसे ये ऊपर गया नीचे आया. How to prepare a frequency distribution? इसको कैसे करेंगे? While preparing a frequency distribution, the following 5 questions need to address. Should we have equal or unequal sized class intervals? How many classes should we have? What should be the size of each class? How should we determine the class limits? How should we get the frequency for each class? Should we have equal or unequal sized class intervals? There are two situations in which unequal sized intervals are used. First, when we have data on income and other similar variables where the range is very high. For example, income per day may range for nearly 0 to many hundred crores of rupees. In such a situation, equal class intervals are not suitable because if the class intervals are of moderate size and equal, there would be a large number of classes. If class intervals are large, we would tend to suppress information on either very small levels or very high levels of income. Second, if a large number of values are concentrated in a small part of the range, equal class intervals would lead to lack of information on many values. In all other classes, in all other cases, equal sized class intervals are used in frequency distributions. How many classes should we have? The number of classes is usually between 6 and 15. In case we are using equal sized class intervals, then number of classes can be the calculated by dividing the range, the difference between the largest and the smallest values of variable, by size of the class intervals. What should be the size of each class? इसको अब करेंगे अब कल।